Hello, greetings from the Count. I am on the Sesame Street television program. Ah. I love to count, and so my friend Mr. Gottschalk, he told me to come and do a lesson on counting. Uh, but he did not mention it was more shapes than counting, which I'm really good at. I wish he taught more the kindergarten class, 'cause I could totally count to 10. Ah, ah. Okay, let's do some geometry, which is not counting. I don't get it. Okay, this definition of secant, it's called secant. It is a line that crosses through a circle. Ah, ah, ah. Now, you might ask, this seems very similar to something we talked about before with a chord. Now, a secant I just mentioned is a line. It goes all the way through the circle like this. But a chord does not go all the way through the line. It is a segment. So any kind of math that we talk about today, and I just got a little bit of Australian accent. I don't know where that came from. I'm sorry. Any kind of math we do will be related to secant and or chord will apply to both. So if it is a line, if it is a segment, it will not matter. It works for both things. First theorem of the lesson says the measure of an angle formed by two lines that intersect inside a circle is, like, do I get to count this? Oh, I don't get to count. This is a fraction. 1/2 the sum of the measures of the intercepted arcs. That's getting really tiring. So, yeah, let's retire you count. I'm getting winded. Yeah. So, here's the thing. If you have secants or chords and they cross inside the circle, here is where they intersect. And yes, we are inside the circle. So if you want to figure out how big this angle is right here, then what you need to look at is how big is the arc in front of it, and basically how big is the arc kind of vertical behind it. Okay? So the angle is equal to half of the sum of those two arcs. Okay, we're not going to look at any kind of proof for this. The proofs are a little bit in depth, so this is going to be kind of one of those, let's just kind of take my word for it type of situations here. Now, besides lines crossing inside circle, we're also going to look at lines crossing outside the circle. And there's still going to be the 1/2 thing involved here, but instead of adding, we're going to subtract the two arcs that they trap, okay? Now there's 3 different scenarios here, as you can see. Number 1, we could have, secants or chords, 2 of them, and it creates an angle. We could have 2 tangents that create an angle in between, and this will still apply. Or we could have a combination, 1 tangent and 1 secant or chord, and that angle is equal to half of the difference of the 2 arcs that it traps. So again, notice here, whenever we have this angle, technically there are two arcs that we're trapping. There's this arc, which is obviously bigger, and this arc that is obviously smaller. And again, if we look at the tangents, here's 2 arcs we're trapping. There's this arc right here, and then there's this arc that's here. And there's something special about those 2 arcs if you haven't noticed. If I kind of make them as close as possible as I can here, there's something special about the sum of those. And the same thing here. Here is technically arc X from there, and then here is arc Y to there. So it's always the arcs that are in between, trapped between the 2 rays of our angle. Okay? And one way I kind of remember this is, if they cross on the inside, notice what type of sign it makes. You kind of tilt your head to the right a little bit. There's kind of a plus sign in there, which is telling me, hey, I need to add. Do you see any kind of plus sign in these types of problems? No. What kind of signs do you see? Well, I kind of see like, hey, there's a minus sign. You could just use one of these lines as a minus sign. There is definitely no plus sign involved here. So you will not be adding, you will be subtracting them. So let's look at a few examples. Solve for y. And y is out here. Y is specifically this arc. Okay. Now, can I assume that this line right here, if I can get something besides white, can we assume that this is a diameter? We cannot. The center is not labeled. You may not assume that this is the center because it is not labeled. So if this angle's 100 degrees, I know this angle's 80 using the straight angle postulate. Let's get a little bit less thick. There we go. There's a little bit thinner. Now, this is one of those angles that's inside, and I can tell, hey, there's the arc in front of it, and there's the arc that's kind of vertical to it. So if I want to kind of set this up, we said the angle is equal to half of the arc plus the other arc. Well, the angle I already know is 80. One of the arcs is the y, the other arc is the 120. So I'm kind of setting myself up here algebraically. Okay, so let's move this up here so we can solve. So now, what I could do with this 1/2 is I could distribute it. I could. But I want to show you a different choice here. We could get rid of this 1/2. Okay, it's 1/2 times this whole thing. So we could just multiply both sides by 2 instead. And that way we don't have to deal with any more fractions. So 160 is really equal to y plus 120. Subtract the 120 over, and y must be 40. Okay, again, that makes sense, right? The two arcs added together, the 40 and the 120, that makes 160 degrees, and half of that should give me my angle, which was this 80. So I had to use the 100 to get to my 80 in order to do this problem in the end. Second example. Now I've got here x I'm referring to is the arc right here. So x is not this angle, x is not that angle or that angle, but it's specifically that arc. So now, this is maybe looking like, well, I've got, here's my plus sign. So I may be adding two arcs together and taking half of it, but I also have this angle that's on the outside of my circle. So maybe I'm going to be subtracting stuff here. Oh, geez, I don't really know what's going on. Let's use that 70, because that's where we actually have some numbers going on here. Where does it go to? It goes all the way up to here and goes all the way over to here. So everything in between is its arc. Now you might go, hey, that's 160. Why isn't this 80? That isn't the angle supposed to be half the arc? If the angle's an inscribed angle, okay, this vertex is not on the circle. Okay, so if the vertex was on the circle like this, then yes, that would be an 80-degree angle. So the 70 is not inscribed, so we can't just take half of its arc. But do notice that 160 is one of the arcs, and what's the other arc that my angle is trapping? It's trapping the x. So this is what the subtracting version here, where the angle, the outside angle, so I might call it the outer angle, is equal to half of the arc minus the other arc. Now, you might ask, well, how do you know which arc is which? One of them should obviously be the bigger arc. The one that's further or farther away, I never know English-wise which term you should technically use there, so I'll call it farther. The arc that's farther away is always going to be the bigger one, and the arc that's closer is always going to be the smaller one. So our outer angle is that 70 degrees. The arc that's further away is the 160, and the arc that's closer is our x. So again, algebra here, what do we need to do? We could again distribute the 1/2, but you don't have to. We could double both sides instead. So we've really got 140 equals 160 minus x. So you could just think mathematically, 160 minus what's 140? Well, x needs to be 20. Okay? Or if you really wanted to, you could subtract the 160 over and see that negative 20 equals negative x. Divide both sides by negative 1, and then finally you can get the negatives to cancel and get your x equals 20. Now, you might ask, why did you have this line? Oh, I wanted to emphasize it more. Why did you have this line and this line and this line even present in there, Mr. G? To confuse you, to try to throw you off, try to get you off your game. Yeah, because I'm going to do that. I'm going to challenge you. That's what I do. Number 3, we got an angle. It's on the outside here. So chances are I'm going to use one of those difference formulas. So the outer angle is equal to half of the what I call the farther arc minus the closer arc. Okay, so the outer angle, hey, that's my 50 degrees. The farther away arc, well, that would be this x here, sweet, minus the closer arc. That would be this guy. And, oh man, I must have left something out because I forgot to give it a value. I didn't give it a value, so what do we do? Uh, let's call it y. Okay. 50 degrees equals 1/2 times x minus y. I've got two variables. Huh. I can't really solve that. What about we don't call it a new variable? Is there some way we could use our old variable? Think about this. Now notice here, these two lines are two tangents. So I mentioned earlier that when you have the two tangent case here, there's only two arcs. There's this guy and there's this guy. And what do both of those arcs add up to be? 360 degrees. So if this arc is x, how big must this arc down here be? It must be 360 minus whatever this one up here is, which is x. So this is going to seem a little tricky here. We're going to take the farther away arc, which is x, and we're going to subtract away quantity, new parenthesis, 360 minus x. So then we kind of end here with a double parenthesis. Now, how do we get rid of the 1/2? Hey, let's double both sides. Do. So now we have 100 equals. Now we need to talk about simplifying this thing. That part. Again, you're going to treat this minus sign like it's a -1, and we're going to distribute -1 to both of those terms. So we have minus 360 minus a negative x, which turns it into a plus x. So we have 100, and then x plus that x makes 2x minus 360. Let's add the 360 over. So we've got 460 equals 2x. Divide by 2, and x is 230 degrees. Which means this guy down here needs to be the other 130. Okay? Now, one thing that could happen, let me jump back to this part here. You might ask, well, what if I don't put parentheses around the 360 minus x? What could go so wrong, Mr. G? What could go so wrong, you ask? Well, I'll show you. If you don't put parentheses here, look what happens. You've got x, and then you see minus x, and you go, hey, well, those cancel out. Sweet. So what do we got here? 100 equals, what would be left over? Minus 360. Hey, there's nothing to solve, so that's my answer. No, you would eliminate your x's if you don't put the parentheses there. That's why they are important. And the last example. Now, we have a circle inscribed in a triangle, or a triangle circumscribed about a circle. The 117 is talking about this arc. The 121 is talking about that arc. X, Y, and Z are all talking about the three angles of our triangle. So let's talk about what we could do here. We could figure out the length, or not length, but the measure of the third remaining arc in this circle. So we have three arcs, all three of which need to add up to be 360. So if we get rid of the two arcs that we know about, we're really subtracting away what here? 238 degrees. So we're left with 122 degrees. So this arc right here, that's 122 degrees. Okay, so now, let me clear this, get some more room here. Angle X, where's it located at? It's outside of the circle. So chances are we're going to be using that outer angle is equal to 1/2 of the farther arc minus the closer arc. So our outer angle is x. How big is the arc farther away? Well, let's look at angle x. Angle x goes all the way to here, out to here, okay? And it touches the circle. We have two tangents, here and here. So the farther away arc would be all the way from here to here. Now, how big is that arc? Well, that is whatever 117 plus 121 was. And earlier we said that was 238 degrees, because that's what we subtracted from 360 to get our 122 arc that we didn't know. How big is the closer arc? Well, the closer arc would be this guy right here, which is the 122. So now, do we need to do any doubling on both sides? Absolutely not. Let's figure this out. What is 238 minus 122? It is 116, and half of 116 makes 58 degrees. Okay, so there's x. Now, since x, y, and z are all the same type of angles, they're all on the outsides, we're probably just going to use this again and again. So let's clear off this here. And let's redo this thing for y this time. Okay, so angle y now, it's our outer angle. So we'll save this. Okay, put you down here. Oh, yeah, we'll put you down. We're gonna put you in the corner. Sorry, baby. See if you guys get that reference. I doubt it. Now, the farther arc. Well, again, let's look at angle y. Here's angle y. Goes all the way from there to there. Points of tangency here and here. So that means the farther arc is really from here all the way around to here. And it's made up of two arcs, the 122 and the 117. So what is 122 and 117 add up to be? 239 degrees minus the closer arc to angle y, which would be just from here to here. And that's the 121. So let's see. 239 minus 121, that makes 118. Half of 118 is 59 degrees. So there's y. Do we need to do the same thing for z? You can, but what might be a much easier option? Well, we now know 2 out of 3 angles in our triangle, so why not just add them together and subtract from 180 to figure out what the remaining one is? So 180 minus 59 minus 58, really we're subtracting away 117 degrees total, which means z better end up being 63 degrees. So you can double check with this formula that z really is 63 degrees, but it should be that. And that is all. I hope you had fun. I'm sorry I got rid of the count there. We were having fun there. So I'll leave you with one more voice. Elmo is going to say goodbye to you.
Hi, boys and girls. My name's Elmo. That's all I have to say. Please watch Sesame Street. My funding's gonna get cut. Bye-bye.